So coding of coronary angiogram is an emerging concept. This work has been published in ACC 2017. The coronary arterial tree has been segmented. So coronary artery angiography segmental classification in 9 segments. Coronary artery lesion description code system in 9 positions. I am presenting a mathematical model. So actually, what is the value of this? This is one model which gives you pre-procedural instant virtual imagination of coronary angiogram and assessment of myocardial ischemia at jeopardy. Actually, the coronary arterial tree has many limitations and the lesion description has many limitations by many societies. This includes different associations define different modes to classify coronary arterial tree. Different variables have been used to define lesion characteristics. Clinical correlation is related to different outcomes by different associations. Coronary anatomy itself is a variable. Variables, various pathological lesions characteristics. And there is a paucity of documentation of coronary circulation in reporting system. So looking to these limitations, I have tried to put a chord. The coronary artery segment classification has been since 75 and they have given different. In AHA, they have divided the tree into 16 segments, CAS investigator 27 segments, BARI in 29 segments. You just tell me out of how many we can remember which is the 25th segment, which is the 19 segments. So make it simple. We have come with this coding of the system. So limitation of arterial segmentation is arterial tree divides into proximal, mid and distal segments depending upon the branch origin. You say middle is between D1 and D2. Vessels are not located at equidistance due to anatomical variations, therefore does not divide the vessel into equidistant segments. Hence gives false instant anatomical virtual image of the lesion location, and because of that you have to look the various angiograms on computer system. For example, this is an angiogram. If you see the D1, D2 is so close. So by definition of the various association, D1, D2 is mid LAD. And if you speak mid LAD, your mind doesn't think that it will be so close. So looking to these limitations, we have put a proposal of mathematical description model to express the code of coronary angiograms. For this, we had our own center experience of 100 patients, where we calculate the length of Indian coronaries, where the left main is around 10 centimeters, 10 millimeters average, LAD 10 to 12 centimeters, the circumflex 6 to 8 centimeters, and RC around 9 to 12 centimeters. So 9 segments. We have divided the 3 arteries into 3 segments, proximal, mid and distal. Each segment 40 millimeters. As we know, the length of average of stent is around 40 millimeter, 48, something like. So we divided the artery into first is 40, second 40, and beyond that is segment 3. So this can be a mental picture you can prepare. These are the 3 segments. Now we come to the lesion. Lesions has been described by different associations, the type 1, type A, B, C by the AHA, type 1, 2, 3, 4 by SCI, syntax as defined by itself. So looking to these different variations in the expression of lesion characteristics, we have come with something else. So we have the considerations, anatomical considerations for defining the lesion characteristics. Since there is a limitation, there is no equidistant anatomical segmentation of coronary arterial tree. There is a variable site of origin of side branches, variable sizes of the branches itself, so the amount of myocardium which is being supplied by that diagonal branch or marginal branch is defined. So variable distance between any 2 branches, which was the basis to divide the vessel into proximal, mid and distal segments, will help us to define the vessel anatomy. So anatomical annotations do not depict the actual virtual anatomical site of the lesion. Looking to these limitations, at the same time in reporting system we have the limitation, there is no consideration of quantitative or qualitative assessment of the TIMI flow in the reporting system, and there is no assessment of microvascular circulation. For example, if you see this angiogram, then the D1, D2 is very small and there is a obtrusive marginal is a big one. It is not expressed unless you see the angiogram. So our proposal was to use a simple, easy to understand, define, express quantitative and qualitative coronary flow assessment, and to have instant virtual imaging of coronary anatomy in our mind. So called coronary artery lesion description code we have produced, and this is 9 segment, 9 position scheme. The first position gives the vessel description, left main, LED, circumflex, something like that, all vessels coded. Second position gives you the segment, first, second and third involved. Third position gives you the degree of percentage stenosis. Fourth position gives you the length of the lesion, type A, B, C, D, E. They have given type 1, 2, 3, 4. They have given type 1, A, B, C. I have given A, B, C, D, E. It has been published in ACC. Type 1, 10 millimeter, 10 to 20, 20 to 30, 30 to 40, and more than 40 is type E. If it is a graftable, it is type E. If it is non-graftable, it is E0. And if it is a 100%, we don't know what is the length of lesion, so it is defined as U. Then fifth position, you describe the vessel coming side branches, whether they are large enough, more than 2 millimeters, or they are less than 2. Whether they are to be given dash or stent, it has to be decided. What is the amount of myocardium being supplied by those side branches. In sixth position, the lesion characteristic, actually it comes, whether lesion is situated of these segments at junction, or the segment is ectotic, or segment has calcification, whether segment has tortuosity, whether the lesion has associated thrombus, or there is a myocardial bridge, or dissection, or present there, or stent is present, whether the stent is patent, restenosis, or thrombus. If none of the features, we have coded 0 features out of this. And this is put in a bracket to specify, yes, we have considered all these 6, 7 features. Position 7, epicardial blood flow, TIMI flow. Position 8, give the myocardial breast microcirculation status. And in position 9, you give dominance, right, left. So this is a chart which explains you position 1 to position 9, and the 6th feature, position 6, Jecto MBDS. It is so mnemonic, you can remember. And if circulation, this is an example, if circulation is right dominant, involved second segment in RCA, 70% stenosis, type B lesion, TIMI 3, TIMI MBG grade 3, you can just write a single line, RCA second segment lesion with 70% stenosis, type B lesion, the acute margin is small, there is no other features, the lesion is simple, TIMI 3, MBG 3, and right dominance. So this will give you immediate picture in your mind. Similarly, we have done the coding of the left main, first position vessel, second position left main is normal, ostial lesion, mid lesion, distal lesion, or bifurcation lesion, degree of stenosis, third position, fourth position, it's usually 10 millimeters, or so it could be a type A or type B lesion, and fifth position, you can look for the calcification, thrombus, dissection, stent, or there is no associate features. In sixth position, you can write dominance. So this is a single table, you can just write in single line. So if you see the first A, left main, ostial, 70%, type A lesion without any associated features, and it's a right dominance. So in single line, if you write it, your mental picture will be there, what is the coronary angiograms. These are the various examples where the code has been shown. For example, in this 5, the vessel is circumflex, segment is first, 90%, type A lesion, there is a small obtuse marginal, and there is no associated features, TIMI 2 flow, myocardial brush 2, and right dominance. Likewise, we can all define. But this has got its own limitations. It does not address the abnormal origin of coronary vessels, the angle of side branches, whether it is a CTO or there is a collateral or retrograde filling. So to conclude my talk, expression of a coronary angiogram by means of a code enables us to imagine an instant virtual coronary angiogram in absence of a stored coronary images. Hence, it is a new, simple, easy to express, understand, and define magnitude of myocardial jeopardy by simple code. Thank you very much.